Okay, let's take a look at page 100, number 14. They give us these two functions, and they tell us that their tangents, when x equals 1/4, meet at a point called P. Find P. So, first thing we got to do is find the tangent line for each one of those guys, then solve them simultaneously so we can figure out where they intersect. So, let's go. First, let's rewrite this. Y equals x to the 1/2, and if we write this one, it's going to be y equals x to the negative 1/2, and then I'm going to go and find the derivative, which is 1/2 x to the negative 1/2. Bring down the 1/2, rewrite the x, and subtract 1 from 1/2, you get negative 1/2. I do this, derivative, negative 1/2 x, and when I take away 1 from 1/2, or negative 1/2, I get negative 3/2. Alright, so now all I got to do is I got to figure out what this is going to be. The derivative is going to be when I put in a 1/4, and it's going to be 1/2 times 1/4 x to the negative 1/2, and you can go ahead and type that in your calculator, and you'll find out that y, or the derivative, is equal to 1. And then I've got my slope, and what I need is I need a point. I've got the x part of my point. The x is 1/4. What I need to find is the y, and if I take the x and plug it in here, the square root of 1/4 is 1/2. So now I got my point. All I got to do is write my equation. Y equals mx plus b. I get 1/2 equals 1 times 1/4 plus b. If I take away 1/4 from 1/2, I get 1/4 is equal to b. I got my slope, I got my y-intercept, and now my equation is y equals x plus 0.25. If I come back over here and do the same thing with this, I've got negative 1/2 times 1/4 to the negative 3/2, and if you take that and plug it in your calculator, you'll find out that it's equal to negative 4. And I've got to find its point. The x is going to be the same. It's 1/4. When I plug it into here, if I plug in 1/4 where x is, it's going to be 1 divided by the square root of 1/4. Well, the square root of 1/4 is 1/2. 1 divided by 1/2 is 2. You can plug it in your calculator if you want to try. 2 is equal to negative 4 times 1/4 plus b. Negative 1/4 times 4. Add 1 to both sides. 3 is equal to b. And then that gives me my equation. Y equals negative 4x plus 3. And now, the point where these two guys intersect, that's what I'm looking for. So, I make them equal to each other. X plus 0.25 is equal to negative 4x plus 3. Add 4x to both sides, you get 5x plus 0.25 is equal to 3. Take away 0.25. 5x is equal to 2.75. 2.75 divided by 5. X is going to equal 11/20. If I take 11/20ths and plug it back into the original equation, and let's pick one of these, it doesn't really make a difference, I'm going to find out that y is equal to 4/5. And keep in mind, I'm plugging it back into one of these guys because these are the guys I'm finding out where they intersect. Alright, so point P is going to be 11/20 4/5. Alright, let's take a look at page 112. Page 112, we got to find the stationary points and we got to figure out what their nature is. Are they minimums, maximums, whatever? So, first thing we're going to do is we're going to rewrite these. So let's see here. X squared is fine. This is going to be plus 54x to the -1. And now when I find the derivative, 2x to the first minus 54x to the -2. And what I'm going to do now is I'm going to find the stationary points by making this equal to 0. And what I find is it's going to be a little easier if I write this back with a positive exponent. So 0 equals 2x minus, and the 54 will stay on top, but the x squared is going to come down so I can make it a positive exponent. And see, what I'm doing is I'm subtracting 2, and if I make it, 2 fractions. And what I need in order to subtract 2 fractions is I need a common denominator. And the common denominator is going to be x squared. So I need to multiply this by x squared and this by x squared. That gives me 2x to the third minus 54 all over x squared. Now you might be like, why'd you bother doing that? Well, the cool thing about fractions is I know how to make them equal to 0. To make this fraction equal to 0, all I got to do is make the numerator equal to 0. Any fraction that has a numerator of 0 is going to equal 0. So at this point I can forget about the denominator, and all I got to do is figure out what's going to make the numerator equal to 0. If I add 54 to both sides, it's going to be 54 is equal to 2x to the third. If I divide by 2, 27 is equal to x to the third. If I take the cube root of both sides, I'm going to find out that x is equal to 3. And see, now I know the x part of my stationary point, and all I've got to do is plug it back in to the original. So 3 squared plus 54 divided by 3, 9 plus 54 divided by 3 is going to equal 27. Y. So the point is going to be 327. And now what I got to do is figure out whether it's a max or a min. If I go back up here to the first derivative and make it a second derivative, so this is going to be 2, and then -2 times -54 is going to be plus 108 x to the -3. And see, now, I mean, if I plug this in here, 2 plus 108 times 3 to the -3, you're going to find out that it's positive. 2 plus 108 times 3 to the -3. It ends up equaling 6. which I don't really care. What I do care about is that the second derivative is greater than 0. If the second derivative is greater than 0, then I know that that point right there is a minimum point, because immediately after the stationary point, this graph goes up, and that makes this a minimum. Alright, let's take a look at the other one. Same deal. What we're going to do is we're going to rewrite this. This is going to be x to the negative 1 minus 3x to the negative 2. Find the derivative. Bring the negative 1, negative 1x to the negative 2 plus 6x to the negative 3. And I make it equal to 0. And I'm going to do the same thing. I'm going to write these guys as fractions. So it's going to be negative 1 over x squared plus 6 over x to the third. So once again, I got this deal where I'm adding fractions. I need to get one denominator. So if I multiply this guy times x and this guy times x, then it's going to be 0 is equal to negative x plus 6 all over x to the third. And if I need to know what's going to make this fraction equal to 0, well, the numerator equaling 0 is going to make that equal to 0. And so then I find out that x is equal to 6. So I take my 6 and plug that back in. 1 over 6 minus 3 over 36, and y is going to equal 1/12. And now all I got to do is figure out is it a max or a min. So I go back to my first derivative, which I didn't label very clearly. My derivative here. So if I'm going to write a second derivative, negative 2 times negative 1 is going to be 2x, and then I take away 1, so it's going to be negative 3, and then minus 18x to the negative 4. And if I plug in my 6, what I'm going to find out is the second derivative is equal to negative 1 over 216, which I don't really care. All I care about is it's negative. And if it's negative, that means that that 6 1/12 is a maximum. All right, thanks.